So welcome to this mechanical engineering course and manufacturing process is the subject here I'm dealing here. So I'm teaching since and having experience of 10 years. So I want to make the mechanical engineering students of uh, second year students, to feel and understand in a free and easy way this manufacturing videos. So I'm making these videos. So let us take the first question here. So explain in details the classification of welding process, ma. So the total the second unit is dealing with the welding process. Here you can see this. What is the explain details in classification of welding process, ma? With suitable examples. So generally we see here the diagram directly. I am going, ma. Welding is divided into two types. That is solid state welding, ma. So solid state you have to do welding, fusion welding. So liquid state, ma. This is the fusion weld means solid is burnt into liquid. Liquid is used here. Again, this fusion means liquid is again it is a autogeneous welding, homogeneous welding, and heterogeneous welding. So autogeneous welding means no filler materials are used in the welding process. Direct the two pieces will join together without filler in the gap. So homogeneous welding, filler material of composition same with base material. What is the base material? What is the workpiece? Same. That only iron means iron is used. Okay, like this. Heterogeneous welding, filler material of composition different from base materials are used here. So this is a heterogeneous welding, ma. Filler material of composition different from the base metals. So workpiece is one type of material and filler material is different type. This also you can use here welding. So taking the definition, ma, welding process are classified primarily into fusion welding. What is a fusion welding means? Melting the base, ma. Melting the base with filler material without filler metal. Sometimes you use filler metal, sometimes you don't use filler material. Solid state welding, joining below melting point using pressures. So that's just the workpiece is brought below the melting point, near to melting point, ma. Then itself the solid two are joined together. No filler metal is here in this case. Major type includes arc welding. Okay, SEMAW, ma. Submerged metal arc welding, MIG metal inert gas, TIG tungsten inert gas. These are the pressurized this one, ma. And gas resistance and solid state friction ultrasonic methods also used in the welding process, designed for specific materials, depends upon the thickness, depends upon the application. So you want to use this arc welding, metal work, metal welding, TIG welding, depends on the thickness of the material, ma. So next second question is taking about types of welding. Describes various types of welding joints. Explain their characteristics with the new need sketch, ma. So here you can say, ma, this is a butt joint, ma. In between V shape, this joint is called butt joint. See, the one workpiece up, one workpiece down. Here this end is joined with the upside. Upside is joined with downside. This is a lap, ma, overlap, one on the other, lapping. Okay. So here corners, ma. Corners are jointed. 90 degrees is made. Edges, ma. Two edges brought together to take the load and they are joined on the upper side. Here also T shape you want to make. Here welding, it will become strong. So these are the types of welding you can see. So butt joint is common, ma. Lap joint is common. T shape, corner shape, edge shape. These are the types of joints. So defining how the metal pieces are aligned, significantly impacting strength, ma. This is depends upon their strength and preparation. So butt means end to end, ma. So this end is broad. This end of workpiece is brought here and workpiece, ma. So lap means overlapping, ma, here. T joints means perpendicular joint, you can tell here. So proper selection involves matching material thicknesses. So thickness should be same, ma. Required strength, edge preparation. So how you are preparing the edges before welding. This is also one of the important things here. And also V grooves. Somewhere we make V grooves to optimize the structural integrity. Okay, this is the one. Next, explain the gas welding process. What is the types of flames there and for applications. So here, you can see this is the inner cone, outer flame envelope. Neutral flame is here. Here, carbonizing flame is here. Excess of acetylene is there. This is carbonizing. Acetylene means carbon is there more. Oxidation flame means excess of oxygen is there. So neutral means both same ratio. The torch is used is inner column. So three types of flames you can sell. Neutral flame, more carbon, more acetylene, more oxygen, excess of oxygen. So this is the oxyacetylene gas. If I'm not wrong, I will read the definition once. Gas welding is a fusion process using high temperature flames. Typically, oxyacetylene, oxygen and acetylene both are mixed over 3000 degrees centigrade. So they can melt anything 3000 degrees. To melt and joint metal parts, often with a filler rod is used. It is portable, versatile and ideal for repairing work. Maintenance, thin section fabrications, very thin sections are there. The three types of mains are neutral flame, oxidation, carbon action, adjusted by varying the oxygen to acetylene ratio. So how much of oxygen, how much of acetylene is coming from the cylinders, that is used here. Applications, it is used for copper based alloys, brass, bronze, zinc, etc. etc. So if I'm not wrong, I'm taking the fourth question. Explain about the oxygen acetylene gas cutting process with a neat sketch. So here you can see oxygen is carried. One here more oxygen, less acetylene. Both are coming from two pipes mixing in the torch, and it is coming as a fire or flame out of this torch. So oxyacetylene gas cutting is a process uses high temperature flames, more temperature flame produced by burning acetylene and oxygen. When both are combination of chemical reaction, they produce heat, which is used to heat the metal to its temperature 900 degrees centigrade approximately. So it is followed by high pressure jet of pure oxygen to oxidize, blow away the molten metals, creating a clean cut often used on ferrous materials. It is used for only cutting the metals, ferrous metals only. So next I am taking the fifth question. Here describe manual metal arc welding or submerged welding process with comparison. So manual means by hand you are doing. Arc welding, submerged arc welding means you are submerged in some liquid or some gas. You are doing welding. That is called as submerged. Manually means directly. It is exposed to environment. It is not exposed to environment. That is the here you can see here. Here this is the submerged welding submerged welding. Here you can see arc is there coming here. This protected gas is there So welding is done here. Workpiece is here. This is electrode uncoated. Supply, power supply is given. Nothing also given. This is the one. Okay. This is what submerged metal arc welding. Okay. Submerged metal arc welding or manual. Same. Is a manual process using a consumable flux coated thick floated to create an arc. So just it will create arc and it will weld it. While submerged arc welding is an automatic, semi-automatic process using a continuous feed wire, electrode and granular flux. Here, continuously electrode is coming. It is in the form of bundle. So it should not stop here. Here also you can see fused covering gases. Flux is used here. It is a submerged arc welding. Inside this flux it is made. Electrode backed up by fillers, rollers. These the rollers are important here. This is the weld portion. So feed electrodes and granule flux to submerge the arc. So it is a versatile it is versatile, portable. You can carry anywhere. It is ideal for field repairs. Whereas submerged arc welding offers high speed, deep penetration welding for heavy plates. Thick plates of lorries, thick plates of buses can be plated by using SAW. Next question. What is explained about TIG and MIG welding process? What is TIG and MIG welding? You want to tell here. So here diagram is there, ma. You can see this is a TIG and MIG welding. So metal inert gas welding, ma. Here tungsten inert gas welding. In tungsten is a not consumable welding here. In MIG welding, this electrode is consumable, ma. Same diagram only here. See, once definition is more than enough for this. I know diagram is not clear. I will update it. So MIG means metal inert gas. TIG means tungsten inert gas. This tungsten is a rod, filler rod, which is not consumable. Here metal inert gas is welded. Welding are both used for arc welding. Arc is coming from the welding process using shielding gases. We also use shielding gases here, but they offer significantly in filler applications and skill levels. MIG uses a continuous consumable wire. So MIG, we are using a continuous wires. Like previously said, rollers are used. Feed for fast production and thick materials. So thick materials. TIG utilizes a non-consumable tungsten. So tungsten inert gas utilizes a non-consumable tungsten electrode and manual filler rod, which offers high precision, clean welds, ideals for thin metals. So you can also use for thin metals. TIG is used for non-consumable, as I said. It is used for filler rods, high precision, clean weld, thin metals. So TIG is this one, MIG is this one, continuous and non-consumable. Only one difference between TIG and MIG here. So here in the diagram you can see here, it is shown. This is a welding part. This is a consumable. This is a non-consumable electrode. So but figure is same here. Seventh one also you can see. Explain about electroslack welding or resistance welding. So this directly I'm going to this here. You see one plate and second plate overlap together. Here one movable arm is there. This is a stationary arm is there. Workpiece is kept here between. So it is supplied by this transformer backside step down transformer. It is supported by single phase AC power. This AC power is coming here. Primary coil doubling in the secondary coil. It is giving current. So these two electrodes pressing and melting this workpiece. Here you can see this is the weld one. AC supply tongue and tongue both. Just it is brought near the melting point. The workpiece is joined together. No fillers are used here because in the electrostatic welding, resistance welding, what happens, this workpiece is brought near the melting point. Then they are pressurized to join together. So here electrostatic welding is a highly productive vertical single pass process by joining thickness of 25 mm. So 25 mm means 2.5 centimeters, 3 centimeters are welded here using resistance heat from molten slags. So you can see molten slags also. Here resistance welding includes spot and seam. So resistance is coming from electricity. Spot and seam welding uses electrical resistance to generate heat and pressure for the fast. Localized welding. Friction welding generates heat via mechanical friction between rotating workpieces. So in the friction working, the rotation is taking place, resulting in a solid state joint. So this is a setup of this resistance welding. So no filler material here, just this metal brought to under pressure, joined together. Next question. Explain friction stir welding. What is the friction stir welding is? See, this is a friction stir welding. One rotating element is there. It is started from here. It is rotated, going backside. So this is a welding area. So this is axial force is used, rotation, welding direction. This is shaft to shoulder. This is the welding seam is there. Okay, this is the workpiece. Both workpiece joined. Then it is a steer is used. The steer will rotate on this roller. And force is applied axially. Here you can see steer welding is a solid state joining process invented in 1991 that uses a non-consumable. This is also a non-consumable rotating tool. Here this is a one case where you are using rotating tool. Generate the friction, like it will make some lines and then it will weld it. Softening materials without melting them. No melting is done here. Softening of the material is done. It produces high strength So more strength materials are developed here. Low distortion joints, no joints, primarily in aluminum and other metals by mechanically stirring the plaster materials. So this is the principle of rotating tool. A cylinder tool with a shoulder pin. This pin is there. This pin is rotating. Our probe is there. It is rotated and plugged into the joint line to clamped workpieces. So ninth question. Okay, explain about thermite welding. Thermite welding is generally used in the aluminum in railways. Directly, I am going to this diagram. See here, it is thermite. In the thermite, a mixture of this metal is mixed. Chemical reaction takes place. That is poured here. It will come here. It will join here. This is the workpiece. Two workpiece kept under the die. So metal comes and deposits here. So it is making the welding here. Generally, where no electricity is there, we make use of thermite welding. Mainly for railways, rails to be joined here. We are using. So thermite welding is a aluminothermic fusion process. So alumina and aluminum is heated fusion process via exothermic reaction. So excess of heat is there coming out of the this portable no power required method. So no power is used. Refractory and sand molds around joint. You need some sand and refractory, which is easily available in remote areas, providing molten iron to weld a large steel components like rails, like pipes, heavy duty machineries, on-site repairs, structural joints. So these are on-sites where no electricity is there. We can use this thermite welding. It is completely a chemical reaction. It is a aluminothermic process, acts as a reducing agent as a metal oxide. So it is also used for a reading. So here in this thermic cubule, you are having aluminum. This aluminum is going under reaction, chemical reaction, and that is becoming liquid. It is coming here. It is settling. It is joining the joints. After that, it is taken out. Used for railways, pipes, etc. etc. 10th question. Describe plasma arc welding, laser beam welding, electron beam welding. So here you can see I will going to take directly this one This electron beam welding cathode is used This cathode is coming cathode light is coming from the passing through this electron beam. This is focusing coils and this is deflection coils, and it is reaching onto this workpiece. It is melting and it is joining these two pieces. So cathode coming from the light, electron beam, only electrons coming from this light we are directed onto the workpiece. It is welding. Some vacuum pipe is there from air to be coming inside. So this is a one type of electron beam welding. Here laser welding in laser welding, this is one glass, this is one glass, this is one glass, this is four sides glasses. All the light photons in the light are directed at the center These are coming here. These are passing through these lenses. They are focused to weld on the workpiece. So this is a we can call reflecting mirrors. In the between light is there, which is focused only photons from the light is taken here. Here only electrons are taken here from the light. Here photons are taken in this one. It is directed to the workpiece to melt and weld. Here you can see this is also what is this? PAM. Okay. So plasma welding. So plasma welding. Plasma, I will go for the definition. Plasma arc welding, laser welding, electron beam welding are high energy density process. So high energy is coming from that, and high density workpiece can be welded here. So for precision, deep penetration joints, deep penetration canals. POW uses a constricted plasma arc welding uses a constricted arc for versatile shielding welding. So laser beam welding uses photons for high speed localized welding. Electron beam utilizes high velocity electrons in the vacuum for deepness. Generally used in the aerospace components, nuclear applications. Thick section. Here also same. This light is joined here. This supply is given. Here the light is in the plasma welding. What is happening here? The shielding gas is used in the plasma. This gas is used and this electricity is passed from this gas two side gas lines. Inside electricity is passed, then it is giving a high flame which is composed onto this workpiece. The workpiece is melting and joining together. So this is the last question mark. So very important the points I have discussed here, which are necessary for your unit 2 welding process, which are very important. So hope you are satisfied, you understand the things. If any suggestions from your side, please post into this channel. I will be correcting for the next problem. Thank you. Thank you listening for this manufacturing process.